Alright, in this video we're going to be looking at how to solve a system of linear equations in two variables. And out of this section we're going to decide whether an ordered pair is a solution to a linear system. We'll be solving linear systems by the substitution method and by the addition method. And also we'll identify systems that do not have exactly one ordered pair solution. It could be no solution, or it could be infinitely many solutions. Alright, all equations in the form of ax plus by equal to c are straight lines when graphed. Now, two such equations are called a system of linear equations, or in short, a linear system. A solution to a system of linear equations in two variables is an ordered pair that satisfies both equations in the system. Like in this case right here, we got this system of equations right here, and it's in two variables, x and y. And we got two equations here, x plus y equal to 7, and x minus y equal to -1. Now the ordered pair 3, 4 satisfies the system. And to prove that, we let x equal to 3 and y equal to 4. And we substitute the x with 3 and the y with 4 in each of these equations here. So for the x plus y equal to 7, if I let x be 3 and the y be 4, if I add 3 plus 4, I would get 7, which is a true statement. And then for x minus y equal to 1, if I do let x be 3 and y equal 4, 3 minus 4 does equal to -1. So we can say that the ordered pair 3, 4 is a solution to the system of equations that's given here. Now let's look at some examples here. In this example, we're going to consider the system 2x minus 3y equal to -4 and 2x plus y equal to 4. We want to determine if each ordered pair is a solution to the system. Starting with this one, the ordered pair 1, 2. So here I'm going to let x equal to 1, because in the ordered pair, your first number is your x-coordinate, the second number is the y-coordinate, so x is equal to 1 and y is equal to 2. And we're going to substitute those values into each of these equations here, starting with the 2x minus 3y equal to -4. I'm going to replace the x with 1. So I have 2 times 1 minus 3 times y. Replace that with 2. That should equal to -4 when I simplify the left-hand side. Now 2 times 1 will be 2, minus 3 times 2, which is 6. That should equal to -4. And if I do 2 minus 6, that would give me -4, which does equal to -4. So I do have a true statement for that first equation. I also have to check the second equation, 2x minus y equal to 4. I'm sorry, 2x plus y equal to 4. Yeah, 2x plus y is equal to 4. That's the equation. So here again, I replace the x with 2. The x with 1, so it'll be 2 times 1 plus y will be replaced with 2. That should equal to 4. Now 2 times 1 will be 2, and then 2 plus 2 does give me 4. And here, this is a true statement. So I can say here that the ordered pair 1, 2 satisfies this system of equation here. So the ordered pair 1, 2 is a solution to the system. I shouldn't say is a solution, it is the solution to that system. Now what about this ordered pair 7, 6? In this case here, the x will be 7 and the y will be 6. The first number is your x coordinate, the second number is your y coordinate. Now I'm going to substitute the x and the y in each of these equations here, starting with 2x minus 3y equal to negative 4. I'm going to replace that x with the 7, so it'll be 2 times 7 minus 3 times y, which is 6, and that's equal to negative 4. And now 2 times 7 will be 14, minus 3 times 6 will be 18, and that should equal to negative 4. If we do 14 minus 8, we would get negative 4. And that's a true statement here. But we also have to check the second equation, 2x plus y equal to 4. For it to be a solution, it must satisfy, the ordered pair must satisfy both equations. Alright, so here it must be true for both equations here. So x will be 7, so it'll be 2 times 7 plus y, which is 6, equal to 4. 2 times 7 will give you 14. Now if I add 14 plus 6, I'm going to get 20. And 20 does not equal to 4. So here I have a false statement. 20 equal to 4 is a false statement. It's true for the first equation, but it's not true for the second. So in this case here, that ordered pair would not be a solution to this system of linear equations. So I can say here that the ordered pair 7, 6 is not a solution to the system. Okay. So that's how we determine whether a given ordered pair would be a solution to any system of linear equations. Alright, next we'll look at how to eliminate a variable using the substitution method. Now, the substitution method does involve converting the system into one equation in one variable by an appropriate substitution. So you're going to take one equation, substitute it for the variable in a second equation. That way you will have one equation in a single variable. And this will be the procedure for solving a system of linear equations by substitution. Number one, you're going to solve either of the equations for one variable in terms of the other. That means you're either going to solve for x or solve for y. Now, if one of the equations is already solved for x or for y, you can skip that step. Now, step number 2 is to substitute the expression found in step 1 into the other equation. This will result in an equation in one variable. Number 3, solve the equation containing one variable. And then number 4, you're going to back substitute the value found in step 3 into one of the original equations. And then you're going to simplify and find the value of the remaining variable. And then finally, you'll check your proposed solution in both of the system's given equations. Alright, now in example 2. Here we're going to solve by the substitution method. And our system of equations is 2x minus 3y is equal to negative 13, and y is equal to 2x plus 7. And what I like to do here is write these side by side. Get 2x minus 3y is equal to negative 13. And the other equation is y is equal to 2x plus 7. Now we can skip step number 1 because we have an equation that's already solved for a variable. In this case, it's solved for y. So it's got y equal to 2x plus 7. Now what I can do here is take whatever y is and substitute it for the y in this first equation. That way I will have an equation in one variable that I can solve for. Okay, so here I'll take that 2x plus 7, which is what y is equal to, and just substitute it for this y in the first equation, 2x minus 3y equal negative 13. So what's going to happen is this. I'm going to have 2x minus 3 times, and I'm going to replace the y with this 2x plus 7. And then that's going to be equal to negative 13. Okay? That's how we apply the substitution method. I'm replacing this y with what this y is equal to. With that second equation, I'm replacing the y in the first equation. That way I'll have an equation in a single variable. And now I'm ready to solve this equation for x in this case. So here, I'm going to simplify by bringing down the 2x. Now that minus 3 will be multiplied by 2x, and the minus 3 will be multiplied by the plus 7 using the distributive property. So minus 3 times 2x is a minus 6x. And then minus 3 times the plus 7 will be a minus 21. And then that's equal to negative 13. Now combining like terms here, 2x minus 6x will be negative 4x. Minus 21 equal negative 13. And I can get that negative 4x by itself by simply adding 21 on both sides. And that will give me negative 4x is equal to negative 13 plus 21 would be 8. So I have negative 4x equal to 8. And then finally divide both sides by negative 4. That would mean x is equal to negative 2. Now don't stop right here because I have to solve for x and for y. I only know what x is. Now we're going to do the back substitution here in one of the original equations here. Since x is equal to 2, and since I already know what y is equal to, in this case y is equal to 2x plus 7, I'll go ahead and substitute the x with this negative 2. Let's use that y equal to 2x plus 7 and replace that x with negative 2. So I got y is equal to 2 times negative 2 plus 7. And then 2 times negative 2 would be negative 4. And then negative 4 plus 7, I will end up with 3. Okay? So now I know what y is. Y is equal to 3, and I know that x is equal to negative 2. So this will be my ordered pair for this system of equations. 2, negative 3. And of course they tell you to check your proposed solution in both systems given equations. I'm going to do it for this one here. Here's the original equation here, so if I do the check, I just simply take that 2x minus 3y equal negative 13, replace the x with negative 2, so I have 2 times negative 2 minus 3 times y, which is 3, that should equal to negative 13. And then 2 times negative 2 will be negative 4, minus 3 times 3, which is 9. That should equal to negative 13, and negative 4 minus 9 does give you negative 13. And then I'll do the same for y equal 2x plus 7. Now here the y is equal to 3. So it'll be 3 is equal to 2 times x, which is negative 2, plus 7. Then 3 should be equal to 2 times negative 2, which is negative 4, plus 7. Now if I add negative 4 to the 7, I would get 3, which is also true. So I can conclude that the ordered pair, negative 2, 3, is the solution to this system of linear equations. Okay, on to example 3, which is another problem that deals with substitution. Here we're going to solve by the substitution method as well. Here we got 3x plus 2y is equal to 4, and 2x plus y is equal to 1. And again, I like to write these side by side. 3x plus 2y is equal to 4. And the other one, 2x plus y is equal to 1. Now notice that we don't have an x or a y equaling to something. We can do this by either solving either equations for one variable in terms of the other. It would be easier to work with a variable that has a coefficient of 1. In this case, that 2x plus y equal to 1, the y coefficient is a 1. So we're going to get that y by itself by moving the 2x over to where the 1 is. I'm going to do that by subtracting 2x on both sides. So that means I'm going to have y is equal to 1 minus 2x. And now I can apply the substitution method by replacing this y in the first equation with 1 minus 2x, because that's what y is equal to. So in this case here, with that 3x plus 2y is equal to 4, I'll bring down the 3x, and then plus 2 times. Now I'm going to substitute this y with that 1 minus 2x. And then that's going to be equal to 4. So now I have an equation in a single variable that I can solve for that variable. Now let's simplify this. In this case, I'm going to solve for x here, so it'll be 3x, and then 2 times 1 will be a plus 2, and then 2 times minus 2x will be minus 4x. And that's equal to 4. Here I'm using the distributive property again. 2 times 1, that's 2. 2 times minus 2x is a minus 4x. Combine like terms here. 3x minus 4x. That's going to be a negative 1x. And then bring down the plus 2. Equal to 4. And now to get that negative 1x by itself, I'm adding 2. I need to subtract 2 on both sides. So it'll be negative 1x equal to 4 minus 2 will be 2. And then to solve for x, I need to divide both sides by negative 1, which will give you x is equal to negative 2. Now I know what x is, I need to find out what y is. Well, since I got y equal to 1 minus 2x, let's use that and substitute the x with negative 2. So here I'm going to have y equal to 1 minus 2 times x, which is negative 2. And then we'll find out what y is. Now, I'm going to bring down the 1. Now, minus 2 times a negative 2 will be a plus 4. So I have y equal to 1 plus 4. And 1 plus 4 is 5. So now, x is equal to negative 2. Y is equal to 5. So the solution for this system of linear equations here would be the ordered pair 2, negative 2, 5. And I'll leave the check up to you. Okay? And what that means is this. If I was to graph these two equations on a coordinate plane, those two lines would cross at this point. Negative 2, 5. Okay. All right, next we'll look at the addition method. Sometimes they call it the elimination method because you're going to eliminate either an x or a y through addition. So here the addition method involves eliminating a variable and ultimately solving an equation containing only one variable. We eliminate a variable by adding the equation so that the sum is an equation containing only one variable. Now the key step is to obtain for one of the variables coefficients that differ only in sign. And to do this, we may need to multiply one or both equations by some non-zero number, so that the coefficients of one of the variables, x or y, become opposites. Then when the two equations are added, this variable is eliminated. And this is the procedure for solving a linear system by addition. If necessary, you may have to rewrite both equations in the form ax plus by equal to c. That means that the x and the y are on the left side and the constant is on the other side. Number 2. If necessary, multiply either equation or both equations by an appropriate non-zero number, so that the sum of the x coefficients or the sum of the y coefficients would be 0. And then number 3, you're going to add the equations in step number 2. And when you do that, you're going to get an equation in one variable. Number 4, solve the equation in one variable. And then you're going to back substitute the value obtained in step 4 in either of the given equations and solve for the other variable. And then finally, you'll check your solutions in both original equations. All right, now let's look at example 4. Here we got 3x plus 2y is equal to 14 and 3x minus 2y equal to 10. And we're going to solve this one by the addition method. So I'm going to go ahead and rewrite these. 3x plus 2y is equal to 14. 3x minus 2y equal to 10. Alright, in this case, they're both in the form of ax plus by equal to c, where the x and the y are on the left side and the constants are on the right side of the equal sign. And we're not going to need to multiply either equation or both equations by non-zero numbers here, because notice I got a plus 2y and a negative 2y. I can go ahead and just simply add those two equations together. If you notice, the plus 2y and the minus 2y will give me 0. So here's what I'm going to add. 3x plus 3x, that's 6x. And that's equal to 14 plus 10, that's going to give me 24. And again, the plus 2y and the minus 2y add up to 0. So now I have an equation that's in a single variable, 6x equal to 24. Now this equation, I can go ahead and solve for x by dividing both sides by 6. That will leave me with x is equal to 4. Now I need to find out what y is. And this is where I do the back substitution here. Now, I can use either of these equations and replace that x with the 4. I'm going to use the first equation, 3x plus 2y is equal to 14. Now, I could have used the second equation if I wanted to, but whichever equation that you choose to use, you're going to get the same y value. So here, x is equal to 4. Replace this x with the 4 in that first equation. So it'll be 3 times x, which is 4, plus 2y equal to 14. Now let's simplify. 3 times 4 is 12, so 12 plus 2y equals 14. Now let's get that 2y by itself by subtracting 12 on both sides. So I'll have 2y is equal to 2. Divide both sides by 2. You're going to get y is equal to 1. So in this case here, the ordered pair, your x is 4, and your y is going to be 1. So the ordered pair 4, 1 is the solution to that system of linear equations. And again, I will leave that check up to you. I'll let you do the check on your own. Alright, here's another example. This one we got 4x plus 5y is equal to 3. And the other equation is 2x minus 3y is equal to 7. Now, if we were to add these directly, we will not be able to eliminate either the x or the y. So that tells me I need to multiply either one of the equations or both equations by a non-zero number. So that way I will be able to eliminate either x or y. It'll be easier to eliminate the y's. The reason for that is this. One's a plus, the other one is a minus. So let's try to eliminate these y's here. Notice the coefficients are 5 and 3. Let's find a least common multiple for 5 and 3. That's going to be the smallest number that is divisible by 5 and divisible by 3. In this case, it would be 15. So, for the first equation, if I want that 5y to be a 15y, I need to multiply that first equation by, in this case, 3. And for the second equation, if I want to make that minus 3y a minus 15y, I need to multiply that bottom equation by 5. Okay. So now, when I multiply the top equation by 3, I'm going to have 3 times 4x, which would be 12x. And then 3 times a plus 5y is going to be a plus 15y. And then that's equal to 3 times 3, which is 9. Now, if I multiply the second equation by 5, that means 5 times 2x will give me 10x. And then 5 times a minus 3y will be a minus 15y. That's equal to 5 times 7, which is 35. And now I can eliminate the y's, because now I have a 15y and a negative 15y. When I add those two together, those 15y's are gone. Now if I add 12x to the 10x, I'm going to get 22x. Equal 9 plus 35, which is 44. So I got 22x equal to 44. And now I'm going to solve for x by dividing both sides by 22. And that will give me x is equal to 2. Now I'm not done with that problem yet, because I also need to find out what y is. Anytime you're finding a solution for a system of linear equations, you're looking for the ordered pair that satisfies those two equations. Okay? I know what x is. I need to find out what y is. In this case here, I need to choose, I'm going to choose the second equation. 2x minus 3y is equal to 7. And then substitute the x with this 2 right here. So here I'm going to have 2 times 2 minus 3y is equal to 7. And now 2 times 2 will be 4, so it'll be 4 minus 3y is equal to 7. And now to get that negative 3y by itself, I'm going to subtract 4 on both sides to get negative 3y is equal to 3. Then divide both sides by negative 3. You'll get y is equal to negative 1. So the solution to this system of equations would be the ordered pair 2, negative 1. X goes first, y goes second. So 2, negative 1 would be the solution to this system of linear equations in example 5. Okay, now there are some cases where the value of one variable could end up being a messy fraction. If that's the case, you may have to try a different way, because the back substitution may lead to some awful or cumbersome arithmetic. Okay, what you can do here is return to the original system and use the addition method to find the value of the other variable, like in this one here, example 6. Here we're going to solve by the addition method. We got 2x equal to 9 plus 3y and 4y equal to 8 minus 3x. Notice they're not written in standard form, where the x and the y are on the left side and the constants on the other side. So with that 2x equal to 9 plus 3y, I need to move that 3y over to where the 2x is. Now when I do that, if I move that 3y over to the left side, it becomes minus 3y. So I get 2x minus 3y is equal to 9. Now for the second equation, 4y is equal to 8 minus 3x, I need to move that minus 3x over to where that 4y is. So when I move that minus 3x over to the left side, it becomes a positive 3x. And I'm putting that in front. And then plus 4y is equal to 8. So now my equations are in standard form. Now notice I can't eliminate a x or the y directly. I need to multiply by an appropriate non-zero number. But notice I can eliminate a y. Let's try to eliminate the y first, because I got a minus 3y and a plus 4y. I need a least common multiple for 3 and 4, which will be 12. Because 12 is divisible by 3, 12 is divisible by 4. And I'm going to go ahead and rewrite those equations here. 2x minus 3y is equal to 9. And 3x plus 4y is equal to 8. And the least common multiple I'm using is 12. So for the first equation, if I want to make that minus 3y a minus 12y, I need to multiply that first equation by 4. And for the second equation, if I want the plus 4y to be a plus 12y, I need to multiply that bottom equation by 3. Okay? So now, multiplying the top equation by 4, I'm going to have 4 times 2x, which would be 8x. And then 4 times a minus 3y will be a minus 12y. And then 4 times 9 equal 36. So I got 8x minus 12y equals to 36. The second equation, if I multiply it by 3, 3 times 3x will be 9x. 3 times plus 4y would be a plus 12y, equal 3 times 8, 24. Now I can go ahead and add those two equations together, because now I have negative 12y and a plus 12y. That's gone. And if I add 8x and 9x, I'm going to get 17x. That's equal to 36 plus 24 will be 60. So I have 17x equal to 60. And now I can divide both sides by 17. that would mean x is equal to, and I'm going to leave this as 60 over 17. Now, as you can see, I have a, quote, messy fraction. And if I was to do back substitution by replacing the x in either one of those equations, I'm going to be coming up with some fractions that might be difficult to simplify. So this is where we return to the original equation and use the addition method again to eliminate the other variable. In this case, we eliminate the y's. Now let's try to use this right here and eliminate the x's here. Now for the x's, I need a least common multiple for that, for 2 and 3. For 2 and 3, that least common multiple would be 6. Okay. So I'm going to go ahead and rewrite these two equations here. 2x minus 3y is equal to 9, and 3x plus 4y is equal to 8. Now, if I want to make the 2x a 6x, I need to multiply that top equation by 3. For the second equation, if I want to make that 3x a 6x, I need to multiply that bottom equation by 2. But I'm going to have a problem here. One of them has to be negative, the other one has to be positive in order for me to eliminate the x's. So what I'm going to do here, I'm going to make that 2 a negative 2. And it really doesn't matter which one you make negative. I could have made the 3 negative because you want to make one of them negative so that you can eliminate the x's in this case. So here's what's going to happen. Multiply the top equation by a positive 3. I'm going to get 3 times 2x, that's 6x. And then 3 times minus 3y is a minus 9y, equal 3 times 9, 27. The second equation, negative 2 times 3x is a negative 6x. And then negative 2 times 4y will be a negative minus 8y, equal 2 times negative 8 would be negative 16. Now I can go ahead and add those two equations together, because 6x and a negative 6x, that's gone. And now negative 9y and a negative 8y added together will be negative 17y, equal 27 and a negative 16 added together will give you 11. So I got 17y equals negative 11. Now I'm going to divide both sides by negative 17. And I'll leave this as y is equal to negative 11 over 17. And that's going to be as far as you can go with that particular problem here. So this is an example where you may have to use the addition method to eliminate an x, and the addition method again to eliminate the y because of the fractions here. So this is the solution to that system of equations here. 60/17, negative 11/17. That is the solution to this system of linear equations. And this dotted line is just separating this part from this part right here. Okay. Alright, next we'll look at, here's another example. 2x is equal to 3y plus 4, and 4x is equal to 3y minus 3 minus 5y. In this case here, we want to solve by the addition method. First of all, the equations have to be in standard form, where the x and the y are on the left side, the constants are on the right side. For this first equation, if I move that 3y over to where the 2x is, I'm going to have this. 2x minus 3y is equal to 4. For the second equation, if I move that minus 5y over to where the 4x is, I'm going to have 4x and then plus 5y equal to 3. Okay. Now I do have a minus 3y and a plus 5y. Let's try to eliminate the y's here in this case. I need a least common multiple for 3 and 5. That's, of course, will be 15. Okay. So let me go ahead and rewrite this. 2x minus 3y is equal to 4. The other one, 4x plus 5y is equal to 3. Now, in this case here, if I want to make, for this first equation, if I want to make this minus 3y a 15y, I need to multiply that top equation by 5. The bottom equation, if I want to make that plus 5y a 15y, I need to multiply the bottom equation by 3. Alright, now, multiplying the top equation by 5 will give me 5 times 2x, which is 10x. And then 5 times minus 3y is a minus 15y. And that's equal to 5 times 4, which is 20. Okay. Multiply the bottom equation by 3 would mean 3 times 4x, which will be 12x. And then 3 times the 5y would be a plus 15y, equal 3 times 3, which is 9. And now I can eliminate the 15y's here. So here, negative 15y and a plus 15y, that's gone. And I'm going to add the two equations together. 10x plus 12x is 22x. And that's equal to 20 plus 9, that would be 29. So here I have the equation 22x is equal to 29. Divide by 22. And notice you have a messy fraction here, x equal to 29 over 22. So now we're going to do the addition method. This time we're going to try to eliminate the x's in this case here. Okay, so I'm going to draw a line here to separate this. Now, in this case here, I'm going to try to eliminate the x's here. I need a LCM, or least common multiple, for 2 and 4. Which is in this case 4. Okay, so again I'm going to write these equations down. Now, if I want to make the 2x in the top equation, if I want that 2x to be a 4x, I need to multiply that top equation by 2. And the bottom equation does have 4x there, so I don't need to multiply the bottom equation here. Now, multiply this top equation by 2, and by the way, they have the same sign. So instead of a positive 2, I need to multiply by negative 2. Because one has to be negative, the other one has to be positive. Okay? So here, if I do negative 2 times 2x, this will be negative 4x. Then negative 2 times the minus 3y will be a plus 6y, equaling to negative 2 times 4, negative 8. The second equation, I'll just rewrite that as 4x plus 5y equal to 3. And then we eliminate our 4x's. Negative 4x and a plus 4x, that's gone. Add 6y and 5y, you'll get 11y, equaling to negative 8 plus 3, negative 5. And then divide both sides by 11. You'll end up with y is equal to negative 5/11. So in this case here, my x value was 29 over 22. and my y value was negative 5/11. So here, that solution would be the ordered pair 29/22 and negative 5/11. Okay. So that's the solution to this system of linear equations using the addition method. Okay. All right. Now, there are some cases where you may have a linear system that may have either no solution or infinitely many solutions. Okay? Now, two lines either intersect at one point, are parallel, or identical. Now, the ones that we did where we got a solution to the ordered pair, those are where two lines intersect at that single point. They could be parallel, meaning that they don't intersect at a single point, or they could be identical, meaning that the lines, one line lies on top of the other. Okay? So here, in this case here, the number of solutions to a system of two linear equations in two variables is given by one of the following. Now, if they intersect at one point, that means you only have exactly one ordered pair solution. If there's no solution, that means that the two lines are parallel, as indicated in this graph here. Infinitely many solutions, that means that the two lines are identical. That means that the lines coincide. That means those lines are the same. So if you look at this right here, what an inconsistent system means that you have a linear system with no solution. That means both variables will be eliminated and you will end up with a false statement like 0 equal to 12. So let's look at this example number 8. Here we're going to solve this system. 5x minus 2y is equal to 4 and negative 10x plus 4y is equal to 7. Okay, what I'm going to try to do here is eliminate a variable. Try to eliminate these x's here. Now, the least common multiple for 5 and 10 is 10. Because 10 is divisible by 5, 10 is divisible by itself. Now, watch what happens with this first equation. If I want the 5x to be 10x, I need to multiply it by 2. And not negative 2, because I've already got the negative here with this negative 10x in the second equation. So let's just do 2 here. If I multiply that top equation by 2, 2 times 5x will be 10x. 2 times a minus 2y will be minus 4y, equaling to 2 times 4, that's 8. And then I'll bring over that second equation, negative 10x plus 4y equal to 7. Now, when I add these two equations here, notice that 10x and negative 10x, that's gone. Also notice that negative 4y and a plus 4y, that too is gone. I'm going to have a 0 on the left side, then that's equal to 8 plus 7, which is 15. 0 equaling to 15 is a false statement. So this is an example of a system of equations that is inconsistent. That's an inconsistent system of equations here. That would mean that this system has no solution. There is no ordered pair that will satisfy that system of equations. And if you were to graph this, that means that your lines are parallel. That means that the lines will not cross the graph, will not cross at a single point. Alright, now the other type will be a consistent system, meaning that the linear system has at least one solution. That means that the lines will intersect or coincide. Now, dependent is a little bit different from being consistent and independent. Because with consistent and being dependent, that means the equations will have infinitely many solutions. That means that the lines will coincide. And both variables will be eliminated, and you'll get a true statement like 10 is equal to 10. Okay? If I go back here, this will be consistent and dependent. This part right here where the two lines intersect, this will be consistent and independent. Okay. So let's look at this example here. We want to solve this system. X equal to 4y minus 8 and 5x minus 20y is equal to negative 40. I'm going to use the substitution method because if you notice, I get x equaling to something here. X equal 4y minus 8. So it'll be easier to use the elimination method, the substitution method. So let's use the substitution method for this system of equations. Since x is equal to 4y minus 8, I will take that 4y minus 8 and substitute it for x in this second equation here. That way I will have an equation in a single variable. Now when I do that, I'm going to have 5 times this x is being substituted with the 4y minus 8, and then minus 20y equal negative 40. Now, simplify the left side using the distributive property. This will be 5 times 4y, which is 20y, minus 5 times 8, which will be 40, and then minus 20y equal negative 40. Okay, 20y minus 20y, that's gone. I'm left with negative 40 equal to negative 40, which is a true statement because negative 40 does equal to negative 40. And when we get something like this, that means we have what we call a dependent system. And if it's dependent, that means that the lines coincide. That means one line will lie on top of the other. Not only that, we have infinitely many solutions for this system of equations. Okay. Okay, so that does conclude this particular video on systems of linear equations in two variables.